In this lesson, you're going to learn how to graph and transform logarithmic functions. So to begin, we're going to consider the function that's exponential, f of x equals 2x. We're going to graph this, and then we're going to graph its inverse. So I'm going to begin by making an xy table to graph this function. And I'm going to plug in -2, and that would give me 1/4. -1 would be 1/2. 0 is 1, 2 to the first is 2, 2 to the second is 4, and 2 to the third is 8. I'm going to graph these points on my coordinate plane. I'm going to do this one here in red. And when I connect these ordered pairs, I see this curve that's formed, my exponential function. And I know it has a horizontal asymptote at y equals 0. And now I'm going to graph the inverse. So I'm going to say x, and I'm going to say f inverse of x. And remember the relationship between a function and its inverse. All it does is it switches your x and your y's. So I'm just going to flip-flop each of the ordered pairs on the left. And now I'm going to graph the inverse. I will do that in blue. So now let's think about what we did with the inverse. If we swap x and y, the equation of f inverse of x would be equivalent to, well, you switch and you would get x equals 2 to the y power. If I switch my x and y from this original f of x function. And now if I think about, well, what is this equivalent to? If I use exponential, or if I think about exponential form and how a log is related, I said to you before, if you just kind of go counterclockwise, this is the same as log, same base 2 of x is equal to y. So what I'm saying to you is f inverse of x is the same as the equation log base 2 of x. So big idea here is that in general, the inverse of f of x equals b to the x power is f inverse of x equals log base b of x. So we can see that an exponential and a logarithm are really just inverses. And that's what I'm stating here. So a logarithm is defined as the inverse of an exponential function. So we're going to analyze logarithmic growth versus logarithmic decay. Notice that they both pass through 1, 0. So let's begin by stating our domain on both. Our domain is going to be from 0 to infinity on our parent function. And here it's also 0 to infinity on our decay. I want to also point out that what makes it logarithmic growth is your base, just like with exponential. If your base is larger than 1, it's logarithmic growth. If it's between 0 and 1, it's a fractional value between them, it's going to be decay. Our range for both would be all real numbers or -infinity to +infinity. It is continuous on our entire domain, so continuous on the interval from 0 to infinity for both. As far as the y-intercept, you should see that we have a vertical asymptote at x equals 0, so it doesn't cross the y-axis. The x-intercept is 1 or 1, 0 as an ordered pair. Vertical asymptote, just mentioned, that's x equals 0. Horizontal asymptote, it does not have one. And let's talk end behavior. So for logarithmic growth, the limit of f of x as x approaches, well, I can't say -infinity because it's never going to cross over this vertical asymptote. So it's really approaching 0. And I'm going to specify, I'm going to say that it's approaching 0 on the positive side of 0. And then what is the function doing? Well, that's the nothing new there. It's approaching -infinity. On the right, that looks as if you're accustomed to seeing it. The limit of f of x as x approaches infinity is positive infinity. It's growing. So similarly with decay, again, we're approaching 0 on the positive side. This time the function's going up on the left and it's dropping on the right, so negative infinity on the right. So now let's practice doing some graphs. So f of x is equal to log base 3 of x. So how are we going to graph this? Well, you may find other methods for doing this, but my go-to method is to actually begin with the inverse or the exponential function, which would be any x, and then it would be 3 to the x power because they would be inverses. And then I'm going to pick a few x values, -1, 0, 1, 2, 3. And I'm going to plug this in. 3 to the negative first is 1/3. 3 to the 0 is 1. 3 squared is 9. And 3 cubed would be 27. And then switch them. So your y's are now, your x's are now 1/3, 1, 3, 9, 27. And your y's would be -1, 0, 1, 2, 3. I just find it easier to think about the inverse and then switch for the logarithm. So this would be x, and this is log base 3 of x. All right. So then you're just going to plot these ordered pairs and get a sense of what your graph looks like. So I plotted my ordered pairs, and there is my logarithmic function. Try this next one on your own. Press play when you're ready to check your answer. So the inverse would be 1/4 to the x. So this would become 4, 1, 1/4, 1/16, and then 1/64. Then you're going to switch them. And then I'm going to plot these. So I have 4, -1, 1, 0, 1/4, 1, 1/16, 2. So getting closer and closer to x equals 0. So of course this would be logarithmic decay. You see it dropping, and also the base is smaller than 1 and greater than 0. Lastly, let's visit our knowledge of transformations, analyzing a, h, b, and k, and seeing how they affect our parent function. So our general equation for this particular one, your a is your leading coefficient, h is your horizontal translations. Remember, they work opposite of what you think. K is your vertical. And here, this little b is still just representing the base of this logarithm. So I don't have another b right here in this particular scenario. I'm going to restrict to just a, h, and k and how that affects things. All right, so let's think about how f of x would be transformed from the parent function. Well, consider what the parent function would be. It would be y equals log base 3 of x. All right, so let's see what's happened. I see this -1 and then this +2, so I've got to think about the correct order. That's my h and k, so I'm going to talk my h first. That's going to be a horizontal translation or shift, and it goes opposite of what we think, so that's going to move to the right 1 unit. And then the +2 is going to do a vertical shift up 2, or vertical translation up 2. All right. The next one, again, if you think about the parent function here, this would be y equals log of 1/4, log base 1/4 of x, rather. Okay, so we actually just graphed this parent function above, and similarly, previously I graphed the one you saw in part A. So how would this transform our parent function from before? Well, we have an a value this time, a -2 out front. So the negative will do a vertical reflection across the x-axis. And then the 2 is going to stretch it by a factor of 2.